recording. We're recordifying now.
Recordifying. I like it. What is going on, SolidWorks nerds?
What's up?
Garrett, how you doing, man?
Good. It is hot in here, man. I don't know, I don't know how it is at your house. Well, I'm not actually in my house. I live almost said I live outside of my house, but I work outside of my house. And the sun hits it in the afternoon, and it's got to be 100 degrees in here. It is roasty. Yeah.
The sun's on the other side of my house, so it stays pretty cool in the office. But
nice. Cool. What's the plan for today, man? What we got going on?
Today we've got some optimization stuff to talk about, right?
Ooh, design studies. I like it.
Design studies. A lot of people don't know that you can actually combine those design studies, or you can actually use them not in conjunction with a simulation study. A lot of people kind of overlook the fact that there's so much more that you can do with it. So we'll talk about a little bit of that. Some of it's going to relate to simulation, but you might also want to take a look at just some basic things too, like, understanding mass properties of what you're designing and how to make it as efficient as possible.
Nice. Yeah, I mean, I really like it. I think it goes along with kind of what we were talking about a little bit last time with like making SolidWorks kind of work for you, as opposed to like going through maybe like a lot of iterations of something, or not working efficiently with SolidWorks, I guess, right? So,
yeah, that's exactly right. I mean, we're going to be making all kinds of changes to the design, but I don't want to have to guess at it, right?
Yeah. Trying to find, there's something that I made and 3D printed. Oh, where did you go? It's in my mess here somewhere. There it is. I made this thing and I 3D printed it, and this is something that I should have used a design study for. You put stuff up in there and it's like just like got a little hopper, and then there's a bar, like a sliding bar here, and this volume is really important. What I should have done is actually used a design study to, once I knew the weight per volume, figure out what that should have been, because it was changing like volumetrically. But honestly, I just printed a bunch of them and then found the one that worked right for the slide. But a design study would have been perfect, because I could just said, I want exactly this value, and had it run a couple of iterations to find it for me. But
definitely, man. That would be a good route to go. We're going to look at something pretty similar here on my end here in a little bit, but
nice.
Where do you want to start?
I think we'll do our tip for the day. I'll go ahead and do that really quick. The tip for the day is a couple of really quick sketching things. So I'll go ahead and show my screen here. Pull up some SolidWorks. And there's just a couple of things I think from probably like essentials, or like when people first start using SolidWorks that they're probably not aware of, right? So if I start drawing a line here, and I want to draw a line that's mostly perpendicular, but it's not horizontal and it's not perpendicular here, like, how do I do that? And whenever anybody says anything about how you do something in SolidWorks, typically you say, well, hit the control key, right? And that's exactly what you would do here, right? If you don't want that relationship to show up, you just hit the control key. You can get it as close to 90 degrees as you want, but it won't actually be locked to that.
I'll be honest, man, I totally forgot about that.
I think
that's a good one.
Yeah, I think one of the other things that I think people often aren't aware of is what the automatic relationships that are going on here. How do you actually get the relationships to do what you want, as opposed to what it's doing for you? So right here, it's inferring that I'm going to do a perpendicular relationship to the previous thing. But what if I wanted to do parallel to something else, right? What you do is you just go over and you highlight that previous thing. When it changes color here, you can see the inference line change direction. right? And that one's really close to that anyway. So if I wanted to go and refer to this, you can see now I'm parallel to that, right? You just go and you touch the thing that you want to reference.
Nice. Hover on it, but don't click on it.
Yep. And yeah, that's the tip I had for you guys for today. Pretty easy.
Good stuff.
Yeah. It can be really frustrating though when you're having to go back and delete those relationships when you didn't want them in the first place. So
yeah, exactly. I've done that more than I probably should have, to be honest.
Oh, and this is the customer hat for the day.
Oh, nice.
Amet.
Good deal.
Yeah.
Down in
Southern Idaho.
Yeah. I was there a couple of times. Rexburg, maybe?
I thought it was Pocatello. No, maybe it is Rexburg. I think you're right.
Yeah.
Yeah. Sorry, Jason, if you see this.
I'm going to have to pull it up now and make sure.
Yeah, they do really cool like welding equipment, like robotic welding equipment from what I remember.
Yeah, they get into some pretty high-end stuff for automation.
I did a PDM implementation down there years ago. So that's pretty cool.
Where are we at here? Oh, yes, Rexburg it is. Close to Pocatello.
Really close, yeah. I think I flew into Pocatello and then drove to Rexburg.
Yeah.
From there.
Anyhow.
Spokane
the travels of our days.
Yeah. Spokane to Seattle to Salt Lake City to Pocatello. To Rexburg on the drive.
Yeah. That's a long day right there.
Oh, yeah.
Well, cool. So, optimization.
Yeah, I think I have the first example, by the way, for this. So I'm going to go ahead and show my screen again.
Yeah, let's do it.
I'll go ahead and get rid of that. If you do have the SOLIDWORKS Essentials files too, you could go follow along with something like this. Also, if this happens to you guys, I think we covered this in a previous lesson. If you have the filter turned on, you can just hit like, what is it, F6 on your keyboard to remove all filters, because that can be super annoying for sure. But what I want to do here is, I've actually already run like a Simulation Express study on here, I believe. All right, I actually need to run it. This is all set up. You can actually get the files. This is part of the essentials. I did change one of the dimensions in here so that there would be some additional stress and stuff in here, but you do need kind of a good simulation study to be able to run this. So you can see there's some high stress in here. Factor of safety right there is below 1. It's down at 0.4. So maybe I want to get the factor of safety up to 1. You can notice there's another option here to optimize. I think this is something a lot of people miss inside of just Simulation Express, something that is, part of this. We can actually set up an optimization study, and you can specify the variables and stuff that you want to control. So we can delete this here. So it was set up from a previous one. So they were controlling the width. That's what we do in the Essentials class, if you're ever interested in that. What I want to do in this case is I just want to do something simpler. I'll just do like the number of spokes. So if I can find it here, there's a 3 in here somewhere.
Different.
Oh, come on. I found it before. We can find it again. Do I need to actually highlight the feature for it to be able to see it? I don't think so. Oh, there it is. There we go. And then I can get rid of this other one. There we go. All right.
Got it.
So down here I have my design study. And we have the range that we want to do. So it doesn't make sense to have any fewer than 3 in here. And I'm going to guess that any more than like 6 probably wouldn't help a whole lot. But you know, I want to test these different ones and see. Basically, what I'm going for here is under constraints. I don't have a whole lot of options you can do based off of the stress, the displacement, or the factor of safety, right? And I'm going to go for a factor of safety here is a minimum of 1. So it's going to run through a couple of simulation studies here and see which one of these is the closest to what I have or what I want.
Very nice.
So we should be able to run that.
Yeah, so everybody has access to Simulation Express that uses SOLIDWORks. And you notice here it also uses Design Express Study. So it is a little bit limited. Like you can only do a single body part and you're pretty limited on what you can actually optimize for. But
yeah,
if it's like a single dimension, this works great.
Yeah, and there you can see the different studies. So it must not have reached it. Let's just go with like 0.5. And maximum of 8 spokes.
There you go. Once you get beyond the limitations of, you know, if you want to incorporate multiple bodies, like do your assembly analysis, or maybe some of it's going to be even based on like thermal analysis results, you can always step up to the Sim Pro package and it'll give you the full optimization there for really anything you want.
Yep. Yeah, and I like in the actual like full design studies, you can optimize multiple variables too. Like you can see that the first one that I did was way above the factor safety of 0.5 that I was looking for.
Yeah.
But we can really tell that, like, you know, optimizing the number of spokes is not going to be the right situation here. What we really want to do is, like, we probably want to actually increase the width of that spoke because it's going to be a lot better at resisting the force that we have. But
yeah.
So yeah, should be fun. My daughter's coming to say hi.
Oh, nice.
Come say hi. You still have grape juice on your face.
We have a guest
say
on
hi.
the show today. Hi.
You wave. There's my coworker. She's always asking what I'm eating with my coworkers today.
I don't have any snacks. I do have some coffee though.
Will you close the door, please? Thank you.
Off to play again.
Yeah.
Is she going to bring you some snacks?
I hope so. I could really use some snacks. So
good call.
Yeah, so we can go ahead and stop sharing there. But
yeah, I like that because it starts simple with the Simulation Express stuff. I think that's where, you know, I had fun kind of getting my feet wet with a little bit of optimization. But some other questions came up at a certain point. It was years ago. Got questions from a customer on trying to optimize volume. Like if I get to a certain level in a tank, was their example, how many gallons is that? Right?
Nice.
So well, I'll kind of walk through a simple example of something like that, but you can even take advantage of, like Garrett said before, multiple levels of this optimization too if you want. So let's see here. We'll jump over.
Yeah, I think a good scenario that I haven't actually gone through is like buoyancy, like trying to put the center of pressure over the center of mass. I can't remember if it's the center of gravity or center of mass. Buoyancy, like defined like where the water line is on a boat and stuff like that is actually a pretty complicated problem to solve that requires a lot of iterations.
Right.
And design study would be perfect for doing something like that.
Definitely. Dude, have you seen some of the stuff they can do with X-Flow for buoyancy?
No. I'm gonna have to check that out.
Drop an object into a fluid and like watch it float. It's pretty cool stuff. Real high-end simulation.
Okay. I'm gonna have to look at that.
you can see my bottle here, right?
Yep.
Looks like a 20 ouncer, but how do we know it's a 20 ouncer?
Because I put 20 ounces in it after I already had created all the molds.
Yeah, exactly. We kind of know based on like a tribal knowledge, right? We can make a bottle about this size, and we're going to put a known volume into it. But
I 3D
let's say
printed it, and a day later I go and check it.
yeah. So let's say we're doing something brand new, and we kind of have to figure out, well, what's the optimal design for the bottle where I can fill the fluid to a certain height, and I know it's going to hold that amount of fluid, so I don't end up with a complete failure here, right?
Mm-hmm.
So one thing I want to point out here too, let's pop into that little shortcut here down at the bottom right corner. If I want to change units, we'll edit our document units real quick. For mass properties, let's go ahead and take volume at US fluid ounces.
Nice.
Figure out if it's actually 20 ounces or not.
So if you were somebody who made, like, let's say tankers or something like that, you could do gallons.
Mm-hmm. Gallons, liters. There's a few other ones in there too, but yeah, for this one, that'll do the job. So what I did on this one, we've basically got two bodies that are going to get connected by whatever geometry I put in between there. So we ended up doing just a revolve boss that connects those two bodies. So now we've got the shell of the bottle itself. This is one of the examples from it.
Uh-oh. I think I lost you, Brandon.
About this. Maybe one way I'd want to.
Are you still there?
Yeah.
Lost you for a minute. Yeah.
Uh-oh.
I think we're back now, though. We're good.
Said my internet connection is unstable. We'll see.
Yeah.
We'll see how that goes. Anyway, with this move copy feature, if you're not real familiar with what that does, you can take these bodies here in a multi-body part design, and you can actually apply. It's basically mates that you're working with here in a part file, right? So what I did was just take the bottle top here and just mated it to a plane. So that's going to be the overall height of my bottle. I can make it concentric with the bottom. So now I've got something that I can actually parametrically control.
Yeah, so now you have a driving dimension to control that.
It's all going to be based on the top of that plane there. Well, the other part of this too is I want that fluid volume to kind of go to a particular location in the bottle.
Mm-hmm.
So maybe what I do is say, well, from the top of the bottle, we're going to offset a plane here. I don't want the fluid to go over 1.25 inches away from the top of the bottle. But how do I know I'm going to get 20 ounces out of that? Something else you can add to this is an intersect feature. And I love this because you can take just an open volume of fluid or an open volume of geometry and actually kind of represent a fluid body on the inside of it.
Yeah, I think intersect is actually one of my favorite features probably in the last, 5 years, probably. Mm-hmm. It's probably been like 5 years since it was released.
I think that was the what's new in 2014, maybe 2013. Okay. It's been there for a bit.
It has. It took me a little while to actually get used to using it, right? Like, yeah, you could create all this different geometry, whether it's a plane, solid body, or surface body, and you could intersect them all, right? And say, hey, show me all the different volumes and stuff that that is creating.
Yeah, it's really cool stuff. So all you have to do here is pick a plane, and then whatever body you want to intersect with that plane, and that can actually create internal regions inside the solid that you've modeled, or I guess if it's a surface body, that would work too. But whatever's on the inside walls of that up to the plane is all we did here. And here's where you're going to want to pay attention to. Depending on what you want out of this, there might be bodies that you get rid of as part of this intersect operation. But here I want to keep everything. I'm actually creating a new body on the inside of this bottle when I do this.
Nice. And it's just going to be up at that water level that you have, right? So you
Mhm.
have the external, the external volume, your green bottle, and then you also have that internal volume
Yep.
that's your water level. Which is really
Exactly. So I got my bodies folder here. You can see the internal body. There's the external body. Quick little shortcut here too. Bring your cursor over this body if you want to hide it. Just hit the tab key. Tab to hide. Garrett, how do I get it back? What's the
cool.
shortcut?
Shift tab.
Yes, sir.
What
Bring
is it
my
like?
cursor back.
Control Shift Tab shows you all hidden bodies or something like that.
Yeah.
I don't even remember.
Yeah, it does. So I can hold down Shift, bring my cursor back here, and just tap the tab key and it'll come right back. But if I do a tab to hide, and if I actually want to see where that body's at, even though it's hidden, Control Shift tab. Now I've got visibility of it. I'm still holding down those 3 keys. All I have to do is just click on the body, and then I let go of the keys.
Nice. And if you had multiple, you could click on each of those separate bodies to bring them back.
Yeah, just keep on clicking. Anyway, so that's where we're at right now. We've got our fluid volume. I could go and take a measurement of this right now, so you can kind of see where we're going with this. If I were to pick a body and then head up to my mass properties tool, by default, because I pre-selected that body, it's going to measure what is the mass properties of that body.
So you're pretty close.
We're really close to 20 ounces right here, but if I wanted to take it to the next level and really dial this thing in, the way that I've got this set up is when I just modify the distance of that plane, everything's going to go along with it. So
I could see this being really important if you had something that was more like like an oil can, like an oil bottle, right? And you have those different volume measurements on the side of the bottle, and you want to you wanted to create that geometry that says fill all these different fill lines and show exactly where those were.
Yeah. Actually, that's the whole reason that this conversation even came up, like the little measurements that you see on devices like this. That's how we explored this in the first place. My brother's actually a driver for a fuel tanker company, and they have those big wooden sticks that they dip down into the tank. So after they go like fill up a gas station, they'll put the stick in there, and whatever it measures out to, they know how many gallons they have left.
Nice.
That was the whole, like, how can I optimize this in SolidWorks? I don't know if I told you this, but the company that makes those tanks, he actually drives one of the trucks that has their tank on it. So
nice.
Pretty cool stuff.
I want to be the company that makes the sticks. I imagine those are those are probably disposable or something. I don't even know. It seems like a consumable.
Yeah. At some point they're a little waterlogged with fuel, I guess is the best way to put it. Nice. They make really good fire starters.
Oh, I bet. Cool.
Anyway,
so how do we actually get into a design study?
Yeah, real simple. You can just right click on one of these tabs down here and say create new design study.
Oh man, I totally did it like, I don't know if it was a different way, right? Because there's so many different ways. And I think I did like the command search and I looked up design study because I totally forgot how to do that. But
I'm trying to remember, is it in the tools menu?
I think so. I can't remember.
I don't know.
It's all good. Maybe it was insert.
Could be.
You already have it open, so it doesn't matter.
Yeah.
That's a much better way than the way I did it. So you have your variable section, you're going to add a new parameter.
Yep. So I've already got a variable that I used here for bottle height. So same as like what you did before, you would just go out and pick the dimension that you want to use for that variable. So let's say for the bottle height, I know that right now I'm under 20 ounces, so I don't want to start any lower than what I'm at right now. So we'll say,
but you're really close.
Yeah, 8.5 is my minimum. We'll start there. Let's say maybe I want to go up to 9.5, and we'll give it like, I don't know, 1/8 inch step size, something like that. Now, because I'm using Sim Professional, I guess I actually have a a Sim Premium license, which includes optimization. I'm going to get some additional inputs I could use down here. So you can put as many variables as you want. You can put as many constraints as you want. These are all based on sensors. So I've got some set up here. This will work a little bit differently, I think, than what we looked at the last time around. But all you have to do is just add a sensor, which, by the way, are really, really powerful. I think these get way underutilized because you can do a whole lot of stuff with it.
Yeah, I really like, I think it's the assembly class that we use it as like a clearance there, right? If there was a clearance that needed to be like maintained, they put a sensor in there. Like if it went, this gap got below a certain value, then
yeah,
basically kind of almost throw like a rebuild error at you.
Yeah, it's pretty
really
cool.
Nice.
Yeah, so you can, like Garrett said, put in dimensions there. You can, even if you've got costing data and stuff you want to base that on to keep the cost down, you got to actually set up your costing templates to do that. But at any rate,
Nice.
This one is just simple mass properties, right? So I could pick mass or volume. I'm interested in volume. And then all you've got to do is pick the body that you want to measure from. So that one there is our fluid volume. You can put alerts on it too if you want it to show you like you said, kind of a rebuild. It's almost a warning, I guess, is kind of what it looks like when it gets below a certain value or something.
I do like in the variables section, when you did like the start here and go like start at 8.5, go to 9.5 and use the step size. I like that it shows how many scenarios it's going to run to. Like right at the top, you have that total number of scenarios. And yesterday I did like an initial run, and then I reduced the scope, and I kept like, then I changed the increment size, right, down even further. So I got even closer to my end result within like, I don't know, 6 decimal places or something like that is what I got to when I was doing like yeah, it was fun.
Very cool. So for this one here, I'll take my volume of that internal body. Now, because I'm going to do another step here, what I'll say is I want it to be between 20 ounces and something. I'll kind of give it a tolerance here. So we'll say at minimum, we want it to be 20 ounces. Maximum, let's say, I don't know, 21 ounces. Now, the optimization part of this is where it starts to get a little interesting. So anybody can do a design study that has SOLIDWORKS, but you're basically limited to variables and constraints unless you have Simulation Professional. All right, so down at the bottom, with Sim Pro, we get that additional section here for goals. So if I wanted to like minimize the mass of one of the components, like I want this to be a bottle that holds at least 20 ounces, maybe a little bit more than that. But I want to try to minimize the amount of material that I'm using for cost purposes, right? So I could put in an additional goal for that because there might be multiple scenarios that actually meet my criteria, and they'll have 20 ounces or more. But I want to pick the one that's most efficient. So
yeah, especially if you're controlling multiple variables, right? You almost end up like the spreadsheet of these ones would work for you.
Yep, exactly. So it's just going to run through all those different scenarios.
So it looks like it's going up now. Finally reached the 20.1.
So if I just make the bottle a 1/4 inch taller, I'm going to meet that first criteria. Now it's starting to dial it in a little bit more here. And by the way, that outer shape of the revolve there is just a spline. Pretty simple shape to get it all connected with.
Yeah, so here we can see like the red that going into like scenario 3 where the volume was too small. Then you hit your window that you set, and then it went red again because the volume got too large. It was outside of your window again.
Yep, exactly. Right. So this is kind of the sweet spot here, is in this range.
So you could run it again, right? You could change your window to 8.75 to 9.125, and then change your increment size to like a 16th or something like that, or 32nd.
Exactly. Yeah,
Nice.
so the big winner here is going to be scenario 3. Looks like it's pretty darn close to 20 ounces. And the cool thing is, if you want to actually play through each one of these and kind of see the end result, you can just click on each one of these column headers. It'll rebuild the model for you.
I think that's really impressive when you have, like, again, multiple variables that you're controlling, and you have like drastically different geometry between like step 1 and step 20, or however many of these you want to run. So
yeah, and it's
very
all
cool.
live data too. So when you're finished, like once you actually click on that column header that you like, you can come back here and the model's updated with that value if you just want to save it and keep running with it from there.
Nice. That's awesome, man.
Yeah. So hopefully some fun ways to look at design studies, and it doesn't stop there. I mean, you guys already saw that there's tons of other things you can do with this. That's just one example.
Nice.
Always fun. What do you think, man?
I mean, I think it's something that I haven't used like a ton. I think even the sensors are something that I've known about for a long time and could have made use of. So I didn't use the design study when I was doing my thing that I showed you guys earlier. This guy. I did use a sensor though, right? So I was changing values, and it's like, oh, okay, that volume isn't what I want, so I'm going to tweak it, and I could have been done. It took me much longer than it should have, right? If I had used the tools that I actually knew about, I would have been done so quickly. But
yeah, for sure.
That's one of the things, like, you may get exposed to it, but you can't remember the name of it at the time, or I don't know. You go back to your old habits, I guess.
Yeah.
Yeah,
that's the truth. I mean, really a lot of those tools that we know are there, you might forget about it. It's pretty easy to do that once you get in a rut with doing things the way you do them.
Yep. So let's see. Did you have the support question for the day? Do I have the support question for the day?
Let me take a look here. Where are we at? Oh yeah, here we go.
Find it?
Garrett, why is my weldment profile or library feature empty?
Well, let me show you.
I know I've seen that a time or two.
Yeah. So for you guys who don't know, library features are actually really cool. So let's say, I'm just going to suppress this for now. If I had something that I wanted to reuse, right, we can go to our design library, and you can actually save out features. Oh, I know that fluid power port doesn't go here, but we can always try, right? And you can just drag and drop, right? And you can reuse stuff, right? Reattach an edge, find the right configuration of the thing that you want, right? Ooh, that's way too big.
Hey, there we go.
Design library feature. And a weldment profile is also a design library. It's a little bit simpler. So a design library feature could either be like actual features, or it could just be a sketch. Right? So if it's a weldment profile, it's just a sketch. The feature that I just showed you with the fluid power ports, that's an actual set of features, and somebody just basically selected it and saved them out. So the thing that people often do, right, they'll create their shape or whatever here. Let's just go with like 120 by 160. So they'll create their shape that they're going to want to use in like a weldment profile and extrude. But what they'll do is go up and they'll do a save as, and they're going to save this as like a library feature. So there's an option. See, I missed it.
Up a little ways. Below the JPEG.
My eyes are broken right now, apparently. Been
Keep
a long
going
day.
down.
Hey, library feature part. And it puts you right in your design library, right? And if this was a weldment profile, then I would want to save it in my actual weldment profiles folder. What you see though is when you do this, you get the behavior like the person was saying, basically that it's an empty document. The reason that is there's a step that we missed. What we need to do if we want this to be a weldment profile, or if we want to save the features that are in the tree into the weldment, or sorry, into the library feature part, you have to select them. It's that simple. All that the person forgot to do is select the feature in the tree. Then you go up and do your save as. It's a matter of whether you pre-select it or post-select it, but there is no post-select option. You always have to pre-select library features.
Yep. Common step that gets missed. And really it makes a lot of sense when you think about it. Like for the more complex library feature parts, there's a bunch of stuff that you've designed to get that feature to work, but you don't necessarily want to carry everything over, like the stock body that you cut out in that fluid power port.
Yeah.
We're not going to select that body. We just want to create the cuts in the new model, right? So that's kind of the whole intent behind pre-selecting those features. Those are what actually gets added to the library.
Yep. Yeah, so speaking of library features and the design library, that's what we're going to talk about next time. So if that's something that you're interested in, just kind of going on this theme of kind of working smarter with SOLIDWORKS that we've done in kind of the last couple of episodes, I think, TriWorks is great for automation. Design studies are great for actually optimizing like our design, right? And working smart with actual design itself. And then a design library component or a library feature just allows us to leverage that work that we've already done and use it again. Right?
Yeah, agreed.
So
should be a lot of fun.
Yeah, I think I got lots of good stuff for that one. So
right on. All right. Well, hope you guys enjoyed some of the tips and tricks and maybe some things that you hadn't thought about yet. So that's it for today. We'll see you on the next one for some design library talk.
Thanks for sticking with us, guys. Have a good one.